Welcome to The Explainer. Today, we're tackling a really tough customer in clinical microbiology, the Burkholderia Cepacia complex. This group of bacteria really forces us to rethink some of our most fundamental lab practices. So let's get right into why it's such a unique challenge. Just so you know, all the information we're about to go through comes from a pretty comprehensive deep search. If you want to dig deeper into the primary literature yourself, you can find a full list of citations in the notebook document that accompanies this. All right, let's jump right into the heart of the matter because this is what makes this bug so weird. Think about it. For almost every other bacteria we deal with, the antibiogram is our roadmap, right? It tells us what drugs to use. Well, with the Burkholderia Cepacia complex, you can pretty much throw that out the window. The major international bodies are literally telling us not to use our standard susceptibility tests to guide patient treatment. That is a huge deal. So we're going to structure our whole conversation around this paradox. First, we'll talk about the clinical challenge. Then we'll cover how to ID it in the lab. After that, we'll really dig into that antimicrobial susceptibility paradox. And we'll wrap up with treatment strategies and why prevention is so critical. Okay, section 1, the clinical challenge. So what makes this organism so feared? Well, it really comes down to who it infects, our most vulnerable patients, especially people with cystic fibrosis or those who are immunocompromised. The thing about an infection with this complex is that it's a total wild card. One person might just carry it with no symptoms at all. Another could see their lung function just plummet. And then there's the big fear, something called Cepacia syndrome. This is a fast-moving, flesh-eating pneumonia with a super high mortality rate. It's so dangerous, in fact, that just being colonized with this bug is often enough to take you off the list for a lung transplant. All right, let's head to the lab. Section 2, laboratory identification. Before you can worry about treatment, you have to know what you're dealing with, and getting this ID right is absolutely critical. So, under the scope, what do you see? Pretty much a textbook gram-negative rod. Straight or slightly curved, usually by themselves. It's our first clue for sure, but it's super generic. It doesn't tell us much on its own, so the real work is just beginning. Now, on the culture plates, this is where things can get a little tricky. Take a look at its behavior on McConkey agar. It starts out looking like your typical non-lactose fermenter. But, and this is a big but, give it a few extra days, maybe 4 to 7, and it can start to slowly oxidize the lactose and turn pink. This is a classic trap. If you're not careful and read your plates late, you could easily mis-ID this thing. Biochemically, it's pretty standard stuff for a non-fermenter. Oxidase positive, though sometimes that reaction can be a little weak or slow to show up, catalase positive, and modal. But the real story here is its built-in armor. We're talking about incredible intrinsic resistance. This isn't something it picks up, it's just born with it. Its outer membrane is tough for drugs to get through, it's got a ton of efflux pumps that just spit antibiotics right back out, and it produces enzymes to chew them up. It's a fortress. And this is exactly why we have to turn to molecular methods. Your standard 16S or RNA gene sequencing, it's just not going to cut it here. The species in this complex are so closely related, 16S can't tell them apart. That's where the recA gene comes in. It's become the gold standard because it has just enough difference in its sequence to let us definitively nail down the species, which, as you can imagine, is crucial for figuring out a patient's prognosis and controlling spread. Okay, now for the main event. Section 3, the antimicrobial susceptibility paradox. This is the big one. We're going to get into why the test we trust for everything else, the antibiogram, just completely fails us when it comes to the Burkholderia Cepacia complex. So, the big question is why? Why can't we trust the results? Let's unpack the actual evidence that has made groups like CLSI and EUCAST say, nope, don't use this test to decide how to treat your patient. The case against using routine AST is pretty much overwhelming. First off, the results are all over the place. One lab gets one MIC, another lab gets a totally different one. It's just not reproducible. Second, the methods don't even agree with each other. Disk diffusion, gradient strips, automated systems, they all give you different answers. But here's the real kicker. There's absolutely zero good data showing that a susceptible result in the lab means the drug will actually work in the patient. The clinical correlation just isn't there. And look, this isn't just a fringe opinion. The two heavyweights in the susceptibility testing world have spoken. EUCAST, the European Committee, is firm, do not use routine AST to guide therapy, period.
And CLSI in the US is about to remove all the clinical breakpoints from their main guidelines. This is a massive shift, a complete departure from how we handle almost every other bacterium.
Now, I know what you might be thinking, but wait, I've seen breakpoints for this bug in the CLSI tables. And you're right, they are there, for now. But look at that warning. These are for epidemiological use only. That means they're for public health labs to track resistance trends in a population over time. They are not, and I can't stress this enough, to be used to decide what antibiotic to give a specific person who is sick right now. All right, section 4. So if we can't trust our tests, how on earth are doctors supposed to treat these infections? Well, they have to fly blind, but with a very specific flight plan. It all comes down to empiric combination therapy. Let's check out a specific example. This is a protocol out of the Netherlands for new isolates in CF patients. And what's really cool about this approach is that it's a month-long eradication course that doesn't use any IVs. It's all about hitting the lungs hard with nebulized drugs to get super high concentrations right where the bugs are, plus an oral antibiotic for systemic coverage. On a broader international scale, the strategy is pretty similar. Hit it hard with a combination of drugs. This list shows the usual suspects. Doctors will typically pick 2 or more of these agents. These are the drugs that over time have shown the best chance of having some activity. You'll see trimethoprim, sulfamethoxazole, ceftazidime, and meropenem used a lot as the foundation for treatment. And what about kids? Well, the general idea is the same. Combination IV therapy is the way to go. For instance, the Scottish guidelines for kids with CF suggest a course of IV therapy, often followed by a long 3-month stretch of inhaled tobramycin to try and stamp it out completely. And for those really tough multi-drug resistant cases, we're starting to see some promising case reports using newer drugs like ceftazidime avibactam. So this brings us to our final section, prevention as the priority. I mean, when treatment is this hard and our tests are unreliable, it becomes painfully clear that the best strategy is to avoid the infection in the first place. An ounce of prevention is worth way more than a pound of cure here.
To prevent it, you first have to know how it spreads. And there are really 2 different stories here. For your average patient in the hospital, the danger is in the environment. We're talking about contaminated sinks, medical gels, saline, that kind of thing. But for patients with cystic fibrosis, the game changes completely. The biggest threat by far is spreading it from one person to another. So your infection control plan has to attack both fronts. Of course, you start with the basics that apply to everyone, meticulous hand hygiene, plus gowns and gloves for contact precautions. But when it comes to CF care, the rules get even stricter. Patient segregation is not a suggestion, it's a non-negotiable standard. We're talking separate wards, separate clinic days, separate waiting rooms, anything to prevent that devastating person-to-person spread. Look, dealing with the Burkholderia Cepacia complex is a tough, evolving challenge. We'd love to hear from you. What are you doing at your hospital? What are your strategies? Share your experiences and any feedback down in the comments. We can all learn from each other. And hey, while you're there, make sure you subscribe for more deep dives like this one. So that leaves us with one final thought to chew on. When you're up against a bug with this much natural resistance, with tests that don't work, and with very few good treatment options, maybe our only real weapons are prevention and surveillance. Maybe the entire battle is won or lost before the infection even starts. What do you think?